Electron configurations can be confusing to students. The easiest way to handle it is for students to remember a diagram such as the one on the left, where we have the 1s, the 2s, the 2p showing. And we would write them just like this: 1s2, 2s2, 2p6, as we follow this diagram on the left with the arrows through it. Now the 1, that represents the energy level. The S represents the sublevel, and the 2 represents the number of electrons that have been put into that sublevel. And of course, we want to remember how many maximum we can put in each one. So lithium has an atomic number of 3, and lithium therefore has 3 electrons, and we'll place them first in the 1s2. Now we've shown 2 of the electrons, and then a 2s1. Now we add up the exponents, and we see right away that these exponents add up to 3, and sure enough, we have 3 electrons. Aluminum has 13 electrons in its neutral state, and therefore we'd start with the 1s2 and the 2s2 and the 2p6. Now at this point we've shown a total of 10 electrons. We just simply add up the exponents. Now we need 13, so we need 3 more. So we're going to go into the 3s2, and then we're going to need a 3p1. Now sure enough, if you look on the periodic table, aluminum sits in the P block, and it's the very first one in the P block on the third row. Argon, which is a noble gas, we're going to have the 1s2, 2s2, and 2p6, just like we did with aluminum. That adds up to our 10 electrons, and then we keep going with 3s2 and 3p6. Now when we're done, we can add these up, and we have a total of 18 electrons. Now, because argon is a noble gas, we can use this to our advantage with anything above argon. We just simply, in brackets, we'll put the symbol for argon, which is Ar. So if we want to do bromine, we would just go bracket, and then Ar, close the bracket, and then we're going to go to the next energy level, which is 4s2. And then, of course, we drop back down to the 3 Ds, and we can hold 10 of them in the Ds. And then we end in a 4p. And, of course, bromine is an halogen, therefore it's going to end in a p5. Now, the bracket represents the 18 electrons. Of course, we have 17 more electrons sitting there, so we have a total of the 35 necessary. This also helps us with something like krypton, where we know krypton is also noble gas, so we can use those 36. So if we want to do something with strontium, we would just go the 5s2, and then now we know we have done the 38 electrons. I hope this helps.